actually not bad. They got a whole bunch of like bigger artists to write songs. SpongeBob and Panic at the Disco wrote one of my favorite songs. No. Is that can you tell it's Panic at the Disco?
So far, 2 people have watched any video. So thank you. The videos on AP. Sometimes I wonder if you ever listen to anything. Just for real. They're on the AP classroom. I can put the links on Canvas if I get time. You could also log into your AP classroom and go to your dashboard. How do you find them, Nisha?
Well, I just looked at the videos and they have a little black arrow by them if they're assigned. So
I just click on assignments and then I click back to home and then there's a bar of them.
Okay.
You were supposed to remind you to do something today at the beginning of class.
What was it?
You got the email.
Oh yeah. Okay. Okay, here we go. Let me make sure I have them. Oh man. Okay. Well, I go look back there.
Have you tried?
No, but you just can't. I'm sure someone's tried. People have tried all sorts of things. When I worked in a prison, which yes, I worked in a prison, the kids would take their like orange peels and banana peels and they'd put water in it and then like try and hide it for weeks. And then they would open that puppy up and hope that they could stomach the alcohol that was produced. Oh, really? Ready? Next. Gases in solution. Might seem weird. You're like, how does a gas dissolve in a solution? When would I ever use that? Well, anyone have a carbonated beverage today besides me? Okay, well, that's a gas that it's dissolved in solution. It's carbon dioxide. All right, we call it carbonated because your beverage here, those bubbles come from the decomposition of carbonic acid. It definitely, if I'm drawing it, it has sugar in it too. So as your hydrogen carbonate or carbonic acid decomposes, it produces water and then carbon dioxide. So the drink is carbonated, carbonate. All right, I'm going to add more of this powder and turn the stir down. This thing is not grounded very well. Has anyone noticed it shocked me every single time? It hurts. The stuff I do for you kids. That is dedication.
We're very thankful for you.
This stuff is called sodium acetate. All right, and I'm going to put a ton of it in. Okay, then I'll just keep on letting that stir and heat. And we'll see if it goes clear in a second. That's gross looking. Okay, next. So the solubility of liquids and solids do not change appreciably with pressure, but it will for a gas. Like you can learn everything you need to know about gases in liquids just by shaking a drink and opening it. So when our drinks bubble over, it's because you take the pressure off the top. We all hear that like psh sound, all right? And that is releasing pressure that's above the liquid, and then all of a sudden the gas can come out. So the solubility of a gas at the bottom in a liquid is directly proportional to the pressure above it. So that's why when you're not paying attention to like the barbecue in July and you open up that Shasta bottle that was shaken and is warm, And then just boom, your white Old Navy flag t-shirt is covered in black cherry Shasta. All right. I have many personal experiences, but that's, you took that pressure off, you weren't paying attention, and boom, everywhere. Okay? So in order to make the gas stay dissolved, we keep it under pressure. Easy enough so far? That's not the same for solids and liquids. Pressure doesn't really matter. All right, so then we get what we call Henry's law. And you don't have to do this math, you just have to understand it. So it says Sg is equal to Kpg, where Sg is the solubility of a gas. So how much gas can be in the liquid. All right, K is Henry's law constant for that gas in that solvent, and that's a number you get from a table. Pg is the partial pressure of the gas above the liquid. So all you really need to know is the solubility of the gas is directly proportional to the pressure above the gas. Once we release it, the bubbles start to come out. But like that drink you get, when you buy it from the store, you can look through there and you don't see bubbles. You only see bubbles once the pressure is released. Easy enough? Okay, your drinks that come in the fountain, they're different. They are bubbling. There was no pressure on top of them at the first place, but they're also not mixed until you push the button. And then the water and the flavoring and the gas combine. You ever gotten a really, really flat drink at a restaurant? That's usually, and it's kind of weird, but they're sort of smart at the same time. If the ice machine is out of ice, usually that triggers a switch that says, don't put the carbon dioxide in. So that someone goes to get a drink and the ice machine's empty and they're like, oh, hey, you need to add ice. It's a really weird combination, but you won't get them mixed. So why the drinks overflow when you get them out of the fountain is because the CO2, which is really H2CO3, is added to the water under no pressure, essentially, or 1 atm, whoops, and then the bubbles come right back out till they reach an equilibrium, and that's when all the bubbles sort of come out, and then they all pop, and then you're just at that equilibrium where they sort of come out. You with me? And it goes flat slow.
What about whenever like the bubbles that stick to the side of the water?
That's just because there is some attraction, intermolecular force between that gas and the wall of that beverage. And then also, this is really nerdy, but you asked, cups aren't always clean. Well, not like you've got cancer hanging out on the side. Like you have the smallest, this can be the smallest piece of dust ever, but it's what we call the nucleation site, and it's where a bubble can form. And the Mentos thing, that's not a reaction. A Mento has trillions of tiny, tiny, tiny dots on it, which are nucleation sites. They're places a bubble can form. So you drop them in, all of them come out at once. What? Lots of powdery things. Same idea. It's pretty cool. It has to be the right kind of dust, but also dust will mix up and then just kind of ruin the whole process. So a Mento is so cool because it stays together, but almost instantly supplies the nucleation site. All right. So anyway, what you need to know about gases is they're the opposite of solids. If I want to dissolve more, I put it under a ton of pressure. I keep it really cold and I don't disturb it. Okay, this has all pretty much dissolved. I need to clean the sides off without burning my hand. Okay, that's not too hot. It will be though. How am I going to do this? I know. I have these little devices called pipettes. All right, now I'm just going to let this cool undisturbed. What's that? Are they talking smack, officer? Oh, that hurt. Don't spray boiling hot stuff on your fingers. Any meth cook should know that rule. Have there ever been Meth Kitchens in Box Elder County officer.
In Boxwood High School. That's why he had to go to the bathroom, so he get a whole lab in there. Whole kitchen.
Well, actually, there's a whole lab for that.
Okay, we will see if we have enough time. You won't be able to see it, but that liquid crystallized on my thumb. So like it's definitely there. Okay. So I will let this sit, hopefully undisturbed, and we'll see if we can get that. It might take more than all class to chill, though, is the only problem. Uh-oh. Is it already crystallizing?
Yeah, like look at that. It's like barely bare. It's bare.
What's there?
I don't know. It's like right.
Oh, I see it.
Yeah. It's like it's not.
We'll see. We'll see. All right. Here's what I can do. They're acetate crystals, or ass crystals for short. Okay. That was low. Come on, come on.
I am 100%.
Let's see here. Okay. Oh, come on. This is not working at all. Solids and liquids. Let me state it. Solids and liquids solubility is not usually affected by pressure. All right. I can't get it, Caitlin. Or yeah, it was you. Or was it Nisha? You can't really see it. It's like, oh, this is so confusing. It's like right there. It doesn't work.
Is it the things that look like bubbles?
Yeah. Okay, here we go. We'll let it cool. I can't touch it again. Here we go. Make sure you take these notes. This is from the video that you dang well please should watch. Here we go. I need to start share again. Why is this board not responding today? It's oh, good question. Is it really on? Okay. The AP test loves when you draw things. They love when you draw solutions. So here we go. Using particulate models for mixtures. These are pretty important. So they can be used for representing interactions between components of a mixture. And so when you do that, you need to show ion size. They want you to show that you understand things, and orientation of solute ions and solvent particles. Okay, we'll describe this. All right, and then you can also, it will represent concentration of components. Now, I'm not going to leave that up there the whole time. You can take a picture of it, and you're going to watch the video of it. You can pause and get this information. But these are the things they're looking for in these drawings. An interaction between the compounds in a mixture, I said compounds, and then components, and then we can represent concentration of components. So here we go. What we have here, and this is just cut straight from the video, which is probably a crime also, but we have salt, which is NaCl, and they may ask you to draw a representation of salt dissolved in water. All right, so they're looking for a couple of things here. They're looking for the correct orientation and the correct size. So what do I mean by orientation? All right, the positive and negative sides of the water molecule have to align themselves the right way. So it is looking for you to put a chloride ion and the plus sides of the water stuck to it, which should make sense. Those are the hydrogens. All right, because positives will be attracted to negatives. We okay with that so far? All right, then it's looking for the Na plus and the oxygen side, or the minus, attracted to it. So that's the orientation. And then they're going to give you 2 points for this. They also want you to remember that anions are bigger than cations because more electron-electron repulsion. Remember that from, I mean, that was a year ago. All right. Okay. Now, chloride, bigger, negative, attracted to positives. We're just looking for that representation. That would be perfect. Sometimes the AP test gives you exact instructions. It will usually say, and the example is going to be like it, use 1 sodium chloride in your drawing. And it will usually give you a limit of waters. And it doesn't matter, but like follow the instructions if they give it to you. All right, so here we go. M plus is an unknown metal cation with a charge of +1. A student dissolves the chloride of the unknown metal, MCl, in enough water to make 100 milliliters of solution. The student then mixes the solution with excess AgNO3, causing AgCl to precipitate. The student collects the precipitate by filtration, dries it, and records the data. Make a drawing that represents the AgNO3 solution before the reaction occurs. Okay, so what I want you to do is draw a picture of this solution before a reaction would occur. Try it. Read that. There's numbers and stuff. The numbers don't necessarily matter for this particular part of this question. This would be a multi-question question on the AP test. What's that? There would be AgNO3 in there. Go ahead. They're put together, but they haven't reacted yet. MCl, metal chloride. So it's a +1. So it's either lithium, sodium, potassium, rubidium, cesium, or francium. Doesn't matter. Okay, so far this is looking all right. I rarely have a good feeling about how this goes. That is the truest statement I've ever heard in my life. Oh, Joe, they know me so well. I thought the mask was helping, but apparently not. I cannot answer that.
Are we your funnest class?
No.
Are we your most distracted class?
Distracted?
Yeah.
Are we better than
Probably. I don't know, 5th hour is pretty amazing, but I've heard someone else in there cheese my car. Cooper Lloyd. I am a driver's ed instructor. I'm a teacher of 150 kids. I find out everything.
There's actually 2 kids in your 5th hour.
They're dead. They are both dead. I'll send them down to you next hour. Yep. Hey, thanks for attending class.
Hey, man, you know what I call myself?
What?
Except I'm retired. But I was the mask cheeser. Because I put a mask on in case there's any cameras who stream my head on.
Oh,
I thought it was clever. Mask cheeser, that's kind of funny.
that is so funny.
I'm done though. The mask cheeser retired. I wanted to have a calling card too.
It'd probably calm down when you come in and close down.
Does anyone know where we are? Or what time we get out of here, I mean? What? 107? Okay. So those crystals are gone. What? I couldn't see them. I don't see them. Right here? Okay, that's there, sorry. There was also stuff at the top I thought you were talking about.
No, I was talking about that. 'Cause I wanna see it really
Okay, I don't know how long that'll stay that way, but,
cool. Drawing uses molecules or just like
all right, should I just show you the answer?
I got the end.
I don't know. Okay, here we go. Uh, okay, I didn't read it very well, I guess. I'm sorry. All right. Shh, shh, shh. I led you astray. Hold on. Oh, I definitely didn't even read this right. I apologize. It does just say NO3 right here. I didn't read that right.
I read that and I was like,
Okay. So here we go. I apologize. Now, please realize this would be 1 point from a 9-point question, probably. Like there'd be math, there'd be other things, but this is just wanting you to draw the basic structure where Ag plus is with water, but the larger molecule here, or larger side, everyone would know that's the oxygen. You don't have to put the minus or the O. All right, and then NO3 is negative, so that would be by the pluses. TA, that video was awesome. She's got her AirPods in. The Hope Squad thing.
that was so good. Yeah.
Oh. This, kids, if you want to be my TA next year, now you know what you got to do. You cannot bring me diet, so he's off the list immediately.
You're not.
Yeah, because you texted me. Okay, listen. Caitlin asked me a question that matters, so you should pay attention to me. She says, does it matter that there's 4 of them? And the answer is no. You could have put 2, you could have put 10, you could have put 1. The number didn't matter. Go ahead.
So roughly, how much of like a partial charge of a water molecule is like the ratio of like that partial charge to a full?
I don't know. That's something I've never studied. Like you could look it up, but it's probably 5 or 6 or more to 1. All right, the other part of this picture is the small and big. The cation, small. The anion, big. You okay with that? Okay. So here, think about orientation of the ions related to the water molecules, dipoles, the size of the ions, which one is bigger and why, in case they ask that question. Anions have more electrons. All right. Now, a student mixes dilute AgNO3 with excess NaCl to form AgCl solid, as represented by the net ionic equation above. Which of the diagrams below best represents? These are extremely common. Like they're on every test I think I've ever seen. Which diagram best represents the ions that are present in significant concentrations in the solution? AgCl does not readily dissolve in water. Have the discussion. Ready, go. All right. How many of you say A? Any A's? Okay, good. B. C. Wow. And D? Okay, good. C is the right answer. Why, Garrett? You were given a pretty good explanation. Listen to him only and don't talk.
Because, well, first off, the Cl or the NaCl is the excess reactant, right? So there's got to be extra Na and Cl, right? Okay. And then we already know that all the Ag can react because it has excess Cl. So Ag is the limiting reactant, so it's all going to react and be the solid at the bottom. There won't be any Ag left in the water.
So no Ag plus, but yes, Cl minus, right? That's your giveaway. Yep.
Wait, so the limiting reactant is what goes into the precipitate? Wait, is that why?
One of them.
So is that why Ag would be a limiting reactant because you know it's going to be part of the precipitate?
No, that doesn't have to be true. I know it because it tells me
Okay,
that.
so you just know that excess automatically grab Na and Cl in it, and then you know Ag goes into precipitate, so you're going to have
Yep. So anything Cl could grab, it would and make it precipitate. All right. Are you all right with that? Okay. We're 7, right? No. Oh.
I've never heard that.
Okay, shush. That was dang funny though. I've never heard that before. All right, here we go. The structure of water molecule and a crystal of LiCl are represented below. Please don't talk. Show the interaction of the components of LiCl, aqueous, meaning it's dissolved, by making a drawing that represents the different particles presented in the solution. Base the particle in your drawing on the particles shown in your representation below. Include only one formula unit of LiCl and no more than 10 molecules of water. Your drawing must include the following details: identity of ions, so symbol and charge, the arrangement and proper orientation of the particles in the solution. Ready, go. Do you think more people would be able to recognize a picture of Joe Biden or of Bernie Sanders right now? Bernie Sanders. Okay, focus though. Focus. My fault. Focus.
The picture that you made?
No. here we go. Are you done? Done? Okay. All of those people over there done. Okay, here we go. I don't know if I clipped the answer or not. I did not. So you should have one Li plus. You should have one Cl minus. Whatever, just a little bit bigger, right? And actually it'd be way bigger in real life, but that's okay. And then Li plus, you should have the little one. I'm sorry. All right, then this would be the pluses, right? Now, those aren't drawn to scale like here and here. Don't worry about one water molecule is smaller than the other. It doesn't really matter. Yeah, like, so that sucked, but you get the idea, right? Okay, this is usually an easy point out of 9, and your goal's 3 or 4 out of 9. So if one of them's easy, take it. Okay, this tells you what it should take. Let's see if we can get this to work. I don't know if it'll be cool, cool enough to work, but we'll give it a shot. Me? I could probably get a 5, yes, but that I wouldn't get a perfect score for sure. They're hard. They're like super hard.
Only one person on most tests is other than full training.
All right. Now, have I warned you enough that this rarely works right? Okay, so if it doesn't work, don't hate me. It's going to be my, is this like give Tom?
But Cooper is sad it's not diet.
Cooper's a loser, so. Thank you, you're the best. All right, here we go. You would almost think that you kids don't care about my diet.
This really doesn't prove that nothing I say is ever going to be right. I said Davidson wasn't it doesn't really talk about anything.
Okay, here we go. We'll see if this works. Now, I don't really need much crystals, so a fork should be plenty if I can get it to fall in. Oh, we're in trouble, kids. Okay, it's probably not cool enough. It's still really warm. Dang it. Let's try it with a lot. I just don't think it had enough time to cool all the way. No, it's not going to work. If I pour the whole thing in, it will turn solid. Magic, right? It's kind of fun to watch. All right, well, I will try it later. I will record. And what's that? Yeah, this thing right here, that's the stir magnet. I can use a staple, paper clip, anything metallic.